Okay, so here's your new stuff for section 3.2. Even attempted random samples can still contain the big bad bias, and therefore the results you were looking for aren't accurate. There are three ways this can happen. An undercoverage bias. An undercoverage bias, this one is your fault if it happens. It occurs when some members of the population are less likely to be chosen in the sample or just left out, or they're completely left out and they cannot be included. And it's because of how you went about getting your sample. These things happen as a result of the organization behind obtaining the sample. Okay, read just above the next example. So on page 214, how long can you sleep in? Let me grab a book. Let's see what we're getting at with undercoverage bias. I'm going to get to page 214. And my notes say to read just above the example. So here we go. Undercoverage leads to bias when the undercovered individuals differ from the population in ways that affect their responses. For example, if you randomly dial landlines, it's likely to underrepresent young people because many younger people exclusively own a cell phone, don't even have a regular landline in the house. If a landline survey is about a tax increase that will help reduce the cost of college, you can bet, I like how they worded that, you can just bet that the proportion in the sample who favor the proposal will be less than the proportion in the entire population because younger people who have to pay their college debt and only own cell phones wouldn't be part of the sample. That's a way to leave people out right there. How long can you sleep in is on page 214. Whoopsie, I missed it. Undercoverage. How long before school starts do students get out of bed on average? Administrators survey a random sample of students on each school bus one morning. Describe how undercoverage might lead to bias in this study. Explain the likely direction of the bias. Okay, this kind of gets a little tricky for you guys. So what they're getting at here is if the administration just has people that ride the bus, they all have to get to their bus stops. And especially in our district, you guys know this, if you're a long way away from the school, you got to get up pretty early. If you're driving, you don't have to get up as early because of the bus stop. So how undercoverage might lead to bias in this study is you're leaving out people that are older, they get to sleep in and leave whenever they want. So explain the direction of the bias. If it's an average of how long before school starts do people have to get up, I'm going to say that number is actually going to be smaller if you include people who drive to school. So the direction of the bias is that this average would be bigger than it actually is. And the truth, the average would be smaller. You guys see what I mean? Okay. Definition. The sampling frame. The sampling frame is a list of individuals from which the sample is chosen. So, for example, if we're just taking people off of a bus, we're leaving out everybody who drives to school. So if we just have like lists of kids on bus, that would be our sampling frame, but it wouldn't be appropriate because it doesn't cover the entire population. A better idea for a sampling frame would be to go to the guidance area, get a list of every student ID of every student in the high school, then randomly pick them from there. Okay, that's number one, the undercoverage bias. That's when you leave people out, and as a result of them being left out and not getting their responses, you've created bias in your data. And in this case, I think since it's the average amount of time they get up before school starts, if you got to catch a bus, I think that number is going to be bigger than it should be. That's the direction of the bias. Number two is a non-response bias. Non-response occurs when an individual who is actually chosen to be part of the sample cannot be contacted. Like you find them and you want them in your sample, but you can't reach them on the phone or whatever, or they refuse to participate. So maybe if a bunch of people refuse to participate for a similar reason, maybe that's going to create a bias in the data. Okay, so let's go to page 215. You got another example to look at for non-response bias, and then I'm gonna read this part up here. Non-response lends to bias when the individuals who can't be contacted or refuse to participate, if they would respond differently from those who do participate, that's going to create bias in your data. Consider a telephone survey that asks people how many hours of television they watch per day. People who are selected but are out of the house won't be able to respond. Because those people probably watch less television than the people who are actually at home when the phone call is made. The mean number of hours obtained for how much people watch TV is likely to be greater than the mean number of hours for the entire population. This sentence is talking about the direction of the bias. The direction is, again, that average is probably bigger than it should be as a result of this non-response bias. How bad is non-response? According to the polling guru Nate Silver, I have no idea who that is, response rates to political polls are dismal. Even polls that make every effort to contact a representative sample of voters now get no more than 10% to complete their surveys. That's been a big deal in the last couple of presidential elections. Those polls don't match what actually happens when people vote. Since people don't respond to these polls, only 10% of people complete the surveys, down from 35% in the 1990s. That's probably a real big reason why those polls end up not being as accurate. Non-response bias, creating polls that aren't that accurate, and that affects how people move their campaign forward and how people think everyone's going to vote. Okay, so here's the actual example. Can they keep the weight off? 300 people participated in a free 12-week weight loss course at a community health clinic. After 1 year, administrators emailed each of the 300 participants to see how much weight they had lost since the end of the course. Only 56 participants responded to the survey. That's well under half. That's under a third. The mean weight loss for the sample is X bar equals 13.6 pounds. Describe how non-response bias might lead to bias in this study. Explain the likely direction of the bias. Okay, if you went through some program to try and lose weight, and then you get a survey later on and you don't answer it, you're probably a person who's not proud of how much weight you lost. Or let me put this the other way. If you're one of the 56 people who respond to the survey, you probably are proud of how much weight you've lost. So the fact that they randomly tried to pick people and follow up with them but didn't get everybody, this almost turns into a volunteer response situation, you know what I mean? And so therefore, I would say the direction of this is that that number is also probably high. The actual population is probably smaller than that. The direction of the bias is that this average is higher than it should be. Okay? There's your non-response. Number 3, a response bias. This occurs when people straight up lie, when there's a pattern of inaccurate responses to a survey questions. Basically, individuals lie. Now, not on purpose just to be jerks. Maybe they're just not comfortable telling the truth. They question the anonymity. Like, for example, if I went and picked a bunch of kids and asked them, high school kids, like Keeneland High School students, and asked them, hey, did you get a high last weekend? Yes or no question. I'm going to guess, because I'm a teacher and there's students in the high school, that even if they did, they're probably not going to tell the truth about that. That's what a response bias would look like. Okay? Read the 2 paragraphs above the next example. Why don't you read those paragraphs and then we'll do the next video.